Can you see the screens, right?
Yeah, I can see. Hello, Chitti Raju. Good morning.
Yeah. Hi. Good morning.
Hey.
Hi, Chiduraju. Good morning. This is Pradeep.
Hi. Good morning.
I, along with Prashant, will be hosting this series of webinar. And in this webinar, we are going to look at the concurrency in Java. Right? This is something that we will be doing today. So there are not many participants, and what we will be doing is we'll be starting with the Java concurrency. The typical bare bones, right? So in the interest that there might be other participants who are very new to concurrency. And in the next series of webinar, we will be taking some advanced topics also. So in this webinar, we are going to cover with the essentials that you need to know when you are beginning with concurrency and why is it so important, right? So we also have Lakshmi Sahiti Kularu. Hi, Lakshmi. Good morning. Okay, so this is a webinar one on Java concurrency. So what are the takeaways? The agenda for this particular session, we are going to understand what is concurrency. There are a few other related terms like concurrency, parallelism, right? We are going to understand the differences between concurrency and parallelism. Then we are going to look at how to work with API, the bare bones API. And we are also going to look at how to create threads, what the different ways to create threads, the life cycle of threads, and how do we manage with threads, right? How, if there are more than one threads, how are we going to synchronize all these threads to share a common data access, right? Common data structure. So we'll begin with what is a concurrency. So typically, earlier, we had this bare metal, and then on top of bare metal, we actually work with operating system, which internally handle multiple programs. Is that correct? So on the bare metal, we install the operating system, and the operating system will run multiple programs in parallel. Is that correct? Let's say, for example, you are working with a notepad and also you're listening to music. So there are two different programs which are running, and it is abstracted by you from the operating system. So this is one good advantage, one good use case, wherein as per the user, he'll be able to leverage both the programs, right? So behind the scenes, the operating system does the hard work of managing two different applications, even though the internal hardware might have only one CPU, one core. Is that correct? How does it do? It actually time slice both applications, and then gives both applications a chance to get.
Hello, Pradeep. I'm not able to hear you now. Hi, Chitti Raju. Hello, Lakshmi. I'm sorry.
Yeah, hi.
There seems to be some trouble. Pradeep will just join back.
Sure.
Yes, please hold on. Just 1 minute. Meanwhile, while Pradeep just joins back, let me share my screen. So we are, whatever slides are there for this webinar, all that is actually available to you. So we'll be putting up the recording also. And under GitHub Saturday Live, there is Java concurrency. So in this repository, so this is a public repository, you can find the slides. So we'll be uploading the slides here. And we also have a YouTube channel. Called Saturday Live Webinars. We just started this last week. So we had a webinar on JavaScript. And today also we had a webinar on JavaScript. So all the recordings will be here. This is a recording from last week. So I'll just share with you these things. We'll also send you an email with all these details. Let me just share. Okay, that's the place where you can find our slides and all the demos, any files that are created during the webinar. And here you'll find the GitHub recordings, YouTube recordings on YouTube. Hi Pradeep. Let me make Pradeep host.
Can you hear me?
Yes, Pradeep.
Okay. Sorry, I got disconnected.
It's going. Recording is going on, Pradeep. Yeah.
Okay. Can you stop the share, Prashant?
Oh, sorry. Yes. Let's drop it as an option. Not going away. New share, pause share, stop share. Yeah. Yes, sir.
Okay. I think we are discussing with the concurrency. That's when we lost, correct?
Yeah, yes, Pradeep.
Yes. So I was talking that at the bare minimum, we have the bare metal. On top of which, we have operating system. The operating system has a feature wherein it can run two different programs, which can run in concurrent. Concurrently means one program will be sharing two programs. Both the programs will be sharing the same CPU, and the operating system will actually make sure that it will time slice the CPU time, so that each of the program will get its share to run the program, right? So this is at the operating system level. Now the same thing, if you think it's a miniature version, like within the program, like let's say for example our Java program, when the JVM is running, it itself can create multiple processors which are lightweight compared to the operating system threads. So whenever we run different programs on the operating system will create operating system threads. These are heavyweight threads, and these are the same threads which will be getting executed on the CPU, right? So now when we create our program, when we create threads from our program, so these are lightweight threads. These are the threads that are created within our Java program, so that we will be able to leverage when the Java program gets executed. So we can create multiple threads, which are processes. We call this as processes, which also executes the same way in the manner in which the different programs execute when done concurrently. Now, what is the advantage? Right? Why do we care for concurrency? Right. So it's not that it's a clean solution that you should apply concurrency everywhere. So there are some trade-offs, right? There are some trade-offs, and there are some advantages also. Now, what guides you to whether you make?
Sorry to interrupt. Your voice is not very clear.
1 second.
Is it better now? Is it better now?
Yeah, better.
Thanks.
Yeah.
Okay. So concurrency is one term which basically this is what we do in Java programs, right? We create multiple threads, and then each of these threads will actually run within the parent context, right? All these are child processes which run in the scope of the parent, which is a Java program, and they will actually take the CPU time and then execute them. Is that correct? So this is what is concurrency. Now the other thing is parallelism. So these are two different things, right? A program which is concurrent might not be a parallel. At the same time, a program which is parallel cannot be concurrent, and a program can be both concurrent and parallel. Okay, so we have understood concurrency. Concurrency means two or more programs or two or more threads are accessing the same CPU cycles, and then they will be sharing the same CPU, but time slashed, right, concurrently. Now, how do you think? You think of this like a running fan, right? So initially the fan will have only 3 blades. So when it rotates, so after some time you'll see that it is instantaneous. That means you'll see infinite number of blades, right? So at the core there are only 3 blades, but when it runs at high speed, you'll feel that there are multiple blades. Same way, like when the context switching between the threads will happen so fast that you will feel that it is instantaneous. Okay. Now we'll understand what is parallelism. So parallelism is a way wherein all the different threads take their own CPU and run on different CPUs. What does that mean, right? So let me explain. In concurrency, all of the threads are trying to access the same CPU cycles. But let us understand that if each of these threads gets its own CPU, its own dedicated CPU, its own core, then we can run different threads parallelly. Is that correct? So that is the meaning of parallelism. So parallelism, at the core, we need multiple cores to be able to run parallelism. So this is the difference between concurrency and parallelism. So for parallelism, you need to have multiple cores. And earlier it was too costly, right? The memory and the CPU are very costly. But in today's context, when the hardwares are getting more cheaper and cheaper, having a dual core or quad core CPU is a norm by in today's context, right? So even the mid desktop computer comes with a basic dual core processor. So instead of increasing the clock speed, the computers manufacturers are actually creating multiple chips, right? Multiple core, and actually shipping as part of the hardware itself. So when the hardware itself is supporting multi-core, right, multi-core processors, then if our program does not leverage the hardware, then we are obviously reducing the throughput. Is that correct? So we are not leveraging the full power of our hardware. So this is why we need to, as a Java developer, we need to be very good at concurrency and parallelism. We need to understand the core concurrency patterns which are provided to us by the framework. Now, why do we really care about understanding this concurrency and parallelism, right? So the other reason is most of the framework or most of our job that we do on a day-to-day basis revolves around the places where we are actually working with a web framework, right? Where we are working with HTTP or web application. So when you are working with web application, most of these frameworks or the container actually are taking the hard work of creating these threads for us. Okay, so that means what? All these frameworks expect our application to be thread safe. So if there is a bug, if there is a bug in our application, or if you have not implemented concurrency correctly in our application, then even the framework, when it makes a callback, there will be it expects our program to be concurrent, or it expects our program to be thread safe. So any bug which we introduced without the knowing the concurrency topics will be very hard to debug, very hard to reproduce, and very hard to test also whether the fix is correctly. Right. So that means that we should be very careful in terms of identifying how to write thread safe applications. There are many ways for us to write thread safe applications, and in this series of webinars, we will be we will be we will be we will be covering each one of them in sequence. Any questions so far? What is concurrency and parallelism? So to summarize, concurrency deals with doing lots of things at once, right? Might be there is only one CPU and we are trying to do multiple things. In this case, synchronization is what we need to look into, right? How two different threads are able to communicate and how they can execute one after another. But parallelism deals with doing lots of things at once, right? Multiple things at once. Like say, for example, we want to download some images from the internet, right? So we can create multiple threads in parallel and execute them, all of them at once. But in case of concurrency, we need to make sure that all of the thread coordinate or synchronize with each other to get things done for us. So this is the difference between concurrency and parallelism. Okay. So let's understand the life cycle of a thread. The life cycle of a thread is a very important topic. So in Java, whenever we create a new thread, so a thread object is created.
Hello, Pradeep. We are not able to hear you.
Yes.
Okay.
So
Okay.
yeah. So in Java, every time we create a thread, we want to work with a thread API. We need to understand what is a thread, right? Thread is a lightweight process, right? And how do you create threads? Threads in Java are just plain Java objects, right? Since Java is an object-oriented programming language, so threads you create by using the API of thread. So there is a class called thread in Java lang package, and when you create an instance of thread, the first thing is it will be a normal Java object. Okay, so first thing is it will become a normal Java object. It is not a process. It is not a process, right? So next time when you want to really spawn a thread, right, from the object, you call the start method, right? So by default, JVM spawns multiple processes, multiple threads, right? For example, garbage collector, right? GC, and one of the thread which executes our program is called the main thread. So main thread is the one which will be executed when the JVM calls the sys public static void main. So within the main thread, if we want to spawn another child process, we have to first create an instance of the thread object. Once after creating the object of thread object, the moment we call the start method, that is when the JVM actually spawns a new process. That's a new thread, right? And then now two threads will be running in parallel. Two threads will be running in parallel. One will be the main thread, and the other will be the new thread that we create. So when we call the start method, so it is actually the thread of the new thread which will be created. The state of the thread will be marked as runnable, right? So when we create a new thread, it is in the state of runnable. It is not yet started. It does not get started. It is just in the runnable state. That means at any given point of time, the JVM might send an instruction for the thread to start running, right? So once the thread is in the runnable state, the JVM will internally call the run method on the particular thread. So what do we do in the run method? The run method is where we put our logic, what we need to execute, and the JVM will call the run method, right? So if we call the run method directly, right? If we call the run method directly on the thread object, so we are not actually creating the thread, we are actually calling just a normal run method, right? This is very important. So we call the start method, the JVM internally will call the run method. So this is the time when the thread is executing, and what all the block, right, all the statements that we have executed within the run method will get executed. And once the run method is complete, the thread will be terminated. That once after terminating, the thread will not even come back to the runnable state. So this is the happy path flow. So first the thread will be in the new state, that's the object, it's a normal Java object. After that, we call the start method. Once we call the start method, it will be in the runnable state. The JVM will then instruct the thread to be run, and then the run method will be called. After executing the run method, it will be terminated, right? So within the run method, right, so the thread can go to sleep state or blocked or waiting state, right? So when does it go? When we actually call the wait method, or whenever we call the sleep method. Whenever we call the sleep method, the thread will go to the blocked state or waiting state. Is that correct? And then how does it come back from the blocked wait state? So from this it can recover back to the runnable, but once it is terminated, it cannot come back to the runnable state. So once it is in waiting state, calling any of these two methods, notify or notify all method on that particular thread, will actually release the lock and make the thread back from blocking or waiting state, and then again it will come back to the runnable state, and then after which the JVM will instruct it to run. Right. So this loop can continue till the thread is there inside the run method. Once the run method is executed, the thread will be into the dead state. Is it clear? Okay. So this is the life cycle of thread. So we'll take an example and then we'll continue. So here I'm inside my IDE. You can see this screen, right?
Yeah, Pradeep, we can see.
So we'll first create a simple thread demo class. We are going to first start with a simple thread class. So okay, so we are going to create our class. First, we are going to create a public static void main. So this is the entry point, and this is where the main thread will start. So there are two ways to create a thread. The one is by extends the thread class. We first create a extend the thread class. The thread class comes from java.lang package, and there is one method that is called the run method. It's called a run method. So the run method is what gets executed when we actually create the thread. So how do we do that? So we actually do this override and public. So any code that we want to execute in this particular thread, we will be writing that in the run method. Now in the main method, right? So this is where our main program or the main thread will execute. So this is where I can create thread is equal to new thread demo. Okay, so this is how we create thread. Now this is a normal Java object. This is normal Java object, and remember we talked about the states. So this is a normal Java object. To convert that into the thread, we need to call the thread1 dot start. Right. So this is going to internally call the run method. So what we are going to do here is I'm going to run through this for loop. So what we can also do is we can actually call the name of the thread. We can also print out the name of the thread. How do you print out? Plus. Thread is a class, and thread has a method called get current thread, and this is a static method. Static method means you'll be able to get the current thread, and the current thread will have the name. Right? So we can also set the name of this particular thread. So thread1 dot set name. So this is how this is it, right? Now what is going to happen is the JVM will call the main thread. It will create a main thread and it will call the main method. Inside the main thread, we are creating the new object. And once we create the new object, we are setting the name of this particular thread. And here is where we call the thread1 dot start. So when we call the start method, remember I told you that it's going to then call the run method. So a new thread will be created, a new child thread will be spawned from the main thread, and it's going to execute. But the main thread is going to continue. So here I'm going to tell the main thread will continue task. Right. And how do I check with? I can again call thread dot current thread dot okay. Get name. Right. So this is going to print, and finally both the threads will terminate. Both the threads will terminate. Let's try this in action. So let's run this program. So we can see here that inside the interrupt child thread, the name of the thread is child thread 1, which is set up here, and this is going to run. This is going to run 10 times. But if you see here, the main thread will continue executing the task main. That means what? The thread after spawning will continue executing and will not wait for the other thread to complete. So this thread is going to run for 10 times and then terminate. So this is how we can create threads. Okay. So in between, we can ask the thread to go to sleep, right? So how do we do that? So we can tell sleep, and we can tell in seconds. And this method throws an exception. So I'm going to surround it by try catch. And then if I try running it again, we can see that the main thread has completed execution. Main thread has completed executing, but the child thread will run after 5 seconds. Right, every 5 seconds. And you can see that the program is still running. So this is where we will be able to create new threads by creating a new thread and calling the start method. So what will happen if I directly call the run method, right? So this is what I wanted to show you. Never call a run method directly. If you call the run method, it's going to run in the same thread. It's going to treat that as a normal Java object and not as a separate thread. So if I run like this, you can see that it will be running in the same main thread only. See, it will be just like a main thread. The name of the thread is main, right? The name of the thread is main thread. So this is how we'll be able to create a thread. But since you know that in Java, a class can extend only one class, right? What if our class does not extend the thread, but internally it extends some other class, right? In that case, we will not be able to extend the threads. So in that case, as you know that in Java we have interfaces, right? A class can implement many interfaces. So we will be able to implement interfaces. So the next example will be to show code where we will be implementing the interfaces. So I'm going to create a new class. So runnable demo. In this case, we are going to implement runnable. And as you know, we need to implement methods, the run method. So if you click on the runnable, it's a functional interface, right? Functional interface means there can be only one abstract run method, and we should implement the run method. So I'm going to just copy this code from the run method and paste it here. Now I can run the public static void main method. So now what I need to do is I can create a thread, child thread, new runnable demo, and and I tell thread. So this is a target object, sorry, the target object, and thread equal to thread, and we pass this. So we created a child thread. So this is an overloaded constructor. If you see here, it takes the runnable object. Now I can actually call this target object and create an object of this and then pass it to the constructor of thread. Now the next time if I call child thread dot start, so it's going to internally call the run method, what is being implemented by the runnable demo. Okay, so now I can continue the next one. So what I'm going to do. Okay, now if I run this particular program, you can see that the child thread will be run, and now this class can extend any other class, right? This gives us the flexibility to still leverage the runnable interface run method, create the threads, but without having to extend the thread class. So I'm going to reduce this to 1 second. Okay, so here you can see the name of the thread is 0. We can also set the priority of this particular thread. So you can also tell dot set name, just the way that we set the name. So child thread. You can also set the priority. Child thread dot set priority. So this will be the priority. If you see here, now max priority is 10 and the min priority is 1. So between this, I will be able to set the priority. Priority means preference, right? For the JVM, when it sees two or more threads, it actually looks at the priority and then it will decide which thread should take which thread to take the priority when taking the time slicing. There's a question here. Any specific advantage of one over other, or situations where we prefer one over the other? Yes. Basically, when we are working with threads, for some threads we want to set the priority, especially when we are working with multiple tasks which has to run. But we want to set the priority so that after finishing task 1, the second task should complete. Is that correct? Only after you place an order, then only the bill should be generated. Is that correct? So in that case, 2 of the threads can have different priorities, and it will make sure that the thread with the highest priority will always get a chance over the other. Otherwise, all the threads are with same priority. Is that correct? So this is another way of creating threads. And notice that these are all why we are discussing. These are the bare minimum APIs which you need to know, because after understanding these things only, we will be able to go to the advanced topics where we will not be working with the nitty-gritty data, right? So this is basically imperative programming, where we actually do the hard work of creating threads, managing the threads and things like that. But Java 5 onwards, we have different concurrency models, wherein these things are done behind the scenes for us, and then we work on higher level abstractions. Okay, any questions? I'll wait for some time to check for questions. Okay, clear? So these are the 2 ways to create a threads, and one is through thread extending the thread class, the other is through the implementing the running interface. Now we have created through threads, right? We have to create it through threads, but how are we going to synchronize? When each of the thread works on a separate data store, then we don't have to worry about accessing the data, right? But when 2 or more threads have to access the same data source, that is when we would need synchronization. Is that correct? So when two or more threads accesses the same data, then we need to ensure that both of the data should be synchronous, both of the threads synchronous and access the data commonly. Otherwise, it will actually create a race condition. So what do you mean by race condition? When two threads try to access the same data in a different manner, in the different order, then each of the thread will set the data, common data, and the data will not be in consistent manner. Let's take an example and I'll show you. Let's say initially the data will be, let's say for example, the state of the data of I is equal to 10. Now there are two threads which are accessing the data, thread A and thread B. If it is thread A and thread B. Now both of them access the data and let's say they want to increment the I value to the next value. So first time A also access the I value and B also access the I value when this is there in the main memory, and this particular data is there in the main memory. Now each thread can have its own cache value of the main memory value attributes, right? So all these attributes, each thread will have access to its own cached value, right? Now that means what? I will also have 10 value here. Here also I will have 10 and B also will have I is equal to 10. So this is different. It's a copy of the data. It's not reference, it's by copy. Now let's say I also tries to increment the data. In that case, the value of I will become 11 here. The I will become 11 here. But B has its cached value of 10. B has a value of cached value is 10. Now B, if it tries to update the value of I, right, and then if it tries to update, so then the cached value of B will be 11, and then this will also be updated to 11. Is it correct? So this is not something that we don't want, right? The I value should be updated to 12 because B should take the latest value of I before updating. Is it correct? So in program we have this notion of I plus plus. Is that correct? I plus plus. So this is as good as I is equal to I plus 1. Now this looks to be an atomic operation. Atomic operation is it should be done only once. It is done as an atomic value, right? But behind the scenes it consists of 3 steps. Behind the scene it consists of 3 steps. What is the first step? Fetch the value of I. The second is increment the value I, and the third step is to set the value back. It consists of 3 things, not an atomic. So it is not an atomic operation. Although it looks like an atomic operation, it is not an atomic operation. It's a sequence of 3 different operations. Is that correct? So how instead, if it is not an atomic operation, so now the thread B, before it updates, should actually take the latest value of I, which is 11, updates its cached value with 11, increment its value with 12, and then send it back. So this is how both the threads should synchronize. Otherwise, they will corrupt the common data. There are 2 ways to do this. One way is to use the volatile keyword. So the volatile is a keyword which we can use it on the instance variable to make sure that the data is guarded and any operations that are done by any threads should actually take the latest value and then work on that. So this is at the attribute level. The second way is to do at the function level. At the function level, when we are doing, we need to use a synchronized keyword. So we need to use synchronized keyword. So synchronized is a keyword which tells that at any point of time when we are trying to access a shared data, when we are accessing the shared data, then we need to work in a synchronized manner. So this also is very important. Let's spend some time understanding what does synchronized do. Now consider an object here. In Java, since everything that we do is revolving around objects, so whenever any thread tries to work on an object, tries to manipulate that particular object, will essentially hold something called as a lock. Will hold something called as a log. In Java, we call this as monitor. Now, whenever a thread tries to access that particular methods of an object, should first acquire the log or the monitor, and then only when it releases the log, right, where it enters the log, tries to modify, no other thread will be able to access that particular object till the current thread exits. So that is the use of synchronized. When you make it a synchronized, then no other thread will be able to access that particular log on the same object until the first thread comes up, right? So within the object, when it is performing the operation, it can go to the sleep state or it can go to the wait state, right? So that is what we call it, wait state, blocked state. So once a thread goes into the wait state or blocked state, it'll it has to be notified by any other thread which again acquires the lock on that particular object till any other thread calls the notify or notify all method. This thread will be in the blocked state. Only when you call the notify all, the thread will be notified, and then again they will try to acquire the lock. This is very important because this is how we will be able to communicate between two threads. So wait, notify, and notify all. These are the three key methods using which you will be able to work with two or more threads when accessing the same shared objects. Now, where are these methods coming from? So these methods are coming from the lang package, right? So if you click on this and let's try this. Object class. In object class, you have these methods. So if you see here, clone, toString, notify all. And if you see that these are native methods. Native methods means because when we create threads using Java, it actually works on the JVM, and the JVM directly create operating system threads, right? That also tells that we cannot create infinite number of threads, right? So there is a limit for us to create the number of threads. Is that correct? Notify, and notify all. Wait, notify, and notify all. All these methods are native methods, right? So now we are going to take one more example where we are going to see this in action. I'll tell you briefly what is that example going to be, and then we will start with that example. So let's take an example of a printer service, right? So we have a printer, and the printer will be accessed by the printer service. So this is the actual hardware, and we are going to have a service that is a printer service, which is going to invoke this method on the print. The printer is going to have a print method, and the printer service is going to invoke this particular printer. Now there will be multiple users who will be using that printer service, and all of theirs they will actually request to print, right? All of them will be able to print. Now there might be multiple users who are trying to access the printer, but we need to ensure that once a particular user gets a lock on this particular printer, no other thread should be able to access the print method until the thread has completed its job. That means it has completed the print method. No matter, even if it goes for waiting a few seconds or is being blocked, we need to ensure that it needs to execute, and then only the next thread should be done. Whoever acquires the lock on that particular printer should complete the job, only after which any other thread will be able to acquire the lock. So this way we ensure that if this user is printing 5 pages and this printer is using 6 pages, now only after printing all the 5 pages, the next thread will be picked up. The next job will be picked up. We don't want one page from here, one page from here, one page from this user. We don't want something like this. We want the thread to synchronize so that once after any of this thread, after acquiring the lock, if it releases, then the next thread, right, will be able to acquire the lock on this. Is that clear? So we are going to demonstrate this particular program using Java. So we are going to create one more thing called synchronization demo. The first thing is we are going to create a class called printer. This is going to be just an entry point for our application. So we're going to create a class called printer. And what does the method contain? This just contains public void printer. And what does it do? It's going to run through this for each. Control. Let's implement it so that it will be easy for us. And then go to light. Oh, plus get name, right? Plus okay. So this is just going to, this is normal method, print method. And what does that do? It actually just runs this. And what I can also do is I can make the thread to sleep for some seconds. Right? So let's say 2 seconds. And then so this is just a normal printer class which is going to print, right? If we are going to give a number, it's going to take that number, print for seconds, one page to get printed, and then after that it's going to print the next page, then it's going to print this. Now this is just a normal class, it is not threaded, right? So it does not know anything about threads. Now we are going to create another class called printer service, and this is going to extend our thread class. Now what does it contain? So it will have a reference to a thread, or I can say job, and it is also going to contain the name of the thread, right? Thread. And then it is also going to have a reference to this particular printer object. Because this is going to spawn the multiple threads and going to call this. So this is going to have a run method, and inside the run method, it's going to call the print method. So that's what we are going to do. So we're going to create a constructor for this, which is going to take the name of the thread, and then also it's going to take the reference to the printer. Now, whenever the users are trying to call this printer service, they're going to call the printer service method on the same printer. So we are going to look at this. So we're going to set the name of this. And we're going to tell this is what we are going to do in the thread. And since it is also contains a run method, we have to override the run method. So in the run method, what we are going to do is we are just going to call the printer dot. That's it. We're just going to call the printer dot print method. Now, after the print method is executed, okay, so this is what we are going to do. And we also need to call the start method, right? So I'm going to call some method called we take int priority. So if job go to null, if it is null, then we're going to tell job equal to new thread name, right? So we're going to set the priority of this particular job, not set priority. What is the priority that we are printing, right? And then finally, what we need to call job dot start, because this is a thread, right? So we need to call the start method. Only when we call the start method, only when you call the start method, it's going to call the run method. So in the run method, what we are doing, we are calling the printer dot print method. So we'll wait for a few minutes here before we continue. Okay. Okay, now that we have done the initialize method, now we are going to call the main method, that is our synchronization logic. So that is what we are going to do here. And I'm going to call public static void main. So in this, what I need to do, we need to call a printer. We're going to use only one object, right? So, but we are going to call two services. What are those services? Printer service job one equal to no printer service, and we are going to call job one, and we are going to pass this printer. And this is going to be job two. Same thing here. Now here, notice that both the printer service, we are passing the same object. Since in Java we have object by reference, the same object we are passing that here, but the name are different. So when we call the initialize method, so if it is null, right? If it is null, we are going to set the new thread. And we just need to initialize this thread. Job one dot initialize with the priority. Let's say, for example, 4. And this one I'm going to call it with 5. So now what will happen when we call this job one dot initialize? Initialize will be called. It is going to create a new thread, and it is going to set the new priority, and then it's going to call the start method. Okay. So now the job is to run this particular code. You can see now it is actually running like this 2 1, right? 2 and 1. We don't want like this. If second is acquired, we want second to be completing the job. So how do we do that? In the printer main method, in the print method, by just running this synchronized keyword. So now if you run, if you see here 2 and 1, 2 and 1, right? And the order is not guaranteed also, right? But if I try running now, since we have told a synchronized block, now we see that 2 2 2 2 2, and then exiting, and then 1. So this is how we'll be able to make it a synchronized. Okay, so this is how we'll be able to work in synchronization.
So Pradeep, I have a question. Synchronized means that's internally it uses lock only, is it?
Yeah, it internally uses lock, correct.
So job 2 was executing first because it is a higher priority, is it?
Yes, yes. That is how we are able to set the priority. So it is not only that we can set the priority, but it is up to the discretion of the JVM to take this account and then do that. But from our side, we can only tell, because when you're creating multiple threads, right, we don't know in what order they are executing, right? So the priority is one way for us to make sure that we set the priority.
Okay.
Because these are all OS threads, right? And the JVM does not have any operating system. JVM will just create these threads. These are OS threads, which are very heavyweight, and then it will be executed on the directly on the operating system, right? JVM has nothing to do with that.
Okay. Yeah, I have only that question.
Okay, so these are like the very low level API. Low level API means we are actually running the synchronous keyword. We are actually creating the threads, right? And we are calling the run method and things like that, right? So in the next session, we're going to see how we can, instead of creating a thread manually, which is not a good way, Java API comes with very nice APIs, which helps us to create the threads out of the box, and lets us work with executors. Executors, we just tell executor to execute the job, and we tell how many jobs, right? So executor will start creating the threads. It'll actually maintain, everything will be done by the executors. So, and we'll see how to create fixed thread pools, cached thread pools, right? How many threads we want to create, right? So all of these things we'll be looking at in the next webinar, because in this webinar we just covered with the basics of thread API in the Java, right? These are very low level APIs, but internally this is what will been used if you look for any other higher order APIs, right? So executor frameworks or fork join pool, whenever we use this, it internally uses these things in the behind the scenes.
Pradeep, thanks. One more question I have.
Okay.
Down below, you have extended printer service from thread. But instead of, I don't know much of Java, but instead of trying to call this dot start, you have created a new thread to which you pass the current thread, this and thread name. Why did you do like that? I mean, can we do it like this dot?
Yeah, this is actually referred to only this particular object, right? Printer service object. This always corresponds to the current this object, right? The printer service. But we are actually creating the object of printer. No, sorry. Job is equal to thread object, right? Thread object we are creating. So that is the reason.
Yeah, like printer service also extends thread.
But you're telling job is equal to new thread, right?
Yeah, you're creating a new thread out of the current thread.
Yes. Because we don't want to call the current thread. We want to create a new thread, and because we are creating multiple threads here, right? We are calling multiple threads here, and on that object we need to call the start method, not on the current thread.
Okay. So this will create one thread and it will create another thread internally now, which will be run.
Yes. So we are calling how many threads? 2 threads we are calling, right? So one will be the main thread, because that is what we are calling from here, right? Initialize, right? This will actually create. See here, we are creating 2 objects. Is that correct? 2 printer service object, but with the same reference to the printer object. That means what we are having like this: 2 printer service object, but both of them having the same printer. Is that correct?
Yeah.
And then only when you do synchronized, it will actually execute. So this synchronous can be done in both places. It can be done on the printer object, or when you are calling that, then also you can synchronize that. When we are calling the print method, right? Where are we calling the print method? Start method. In the run method, right? So here also we can make it synchronized. You can call this, and then we can call. This is also possible. So here the client is taking the ownership of running it in synchronized, But here the source itself is synchronous. So that means what? The client need not have to worry. The client can directly call the print method. But if the problem here is every client has to do this, if in that case, right? So this is something that we don't want.
Okay. Thanks for that.
Okay, so in the next session we are going to look at other models, right? Other models where we will actually run a classical interview question, that is producer consumer, right? So why it is useful is we'll have a case where we are going to mimic an inventory where we are going to have a common data structure, and the producer will be producing and the consumer will be consuming. So there will be the infrastructure or the inventory will have limited size. Is that correct? Let's say, for example, they have only the capacity of maintaining 10 products. Now, once the producer start producing, we need to make sure that once the capacity is full, the producer should not produce. Is that correct? Right? Until the consumer starts consuming. Now the consumer also, once it consumes all of the products, then the consumer, there is nothing to consume. So the consumer has to wait till the producer puts it. And these two things are separate threads. So how do we solve this producer consumer problem, right? So the producer will start producing and will block or hold till the consumer consumes. The consumer also start consuming till it consumes everything and there is no more thing to consume. In that case, the consumer will send a notification to notify. And once the producer has produced, he will also notify the consumer to consume. So this model can be easily implemented using wait, notify all, using the synchronization technique. And later we will see how this is already been done by you by higher level abstractions in the next class. Okay. Okay. Thanks everyone. Thanks for joining this session.
Thanks.